Hello, this is Kristen
and Scott, and we're going to go over the lesson 11 genetics problems and talk about how we got the answers that we did.
Okay, so for question number 1, it just asks you a bunch of questions about translation, and for part A it says to indicate the groups of enzymes that are linked to amino acids tRNA molecules, and that answer is amino acyl tRNA synthetases. For B, it says what are the 4 proteins that consume GTP during translation, and it should be IF2, IF3, EF2, EFG, RF1, and RF2. Part C, indicate one molecule that functions as a ribozyme. The 23S RNA functions as a ribozyme. Part D, it says indicate 2 proteins that recognize stop codons, and it will be RF2 and RF1. And then part E says indicate one molecule that forms hydrogen bonds with the Shine-Del-Carmel sequence, and it will be the 16S RNA.
So for part 2, it's fill in the blank. And so it has some statements and asks us to fill in questions or fill in the answers to the blanks. So the first one asks about amino acids and prokaryote proteins, what the first amino acid is. And so in a sequence of RNA, the first sequence will always be AUG, which will always code for methionine or FMET. The next one asks about E. coli, an E. coli protein, which is EFTU. And this one will deliver charged tRNAs to the A site of the ribosome during translation elongation. And then the next one asks about some sites on a ribosome. The initiator tRNA binds to the P site of the ribosome, whereas the remaining charged tRNAs bind to the A site. So if you have there's a lower part of the ribosome and the upper part, then you have A site here, P, and the E site, and so D site. And so the P site of the ribosome right here, that's where the initiator binds the ribosome. The tRNA will bind to the ribosome here and allow the nucleotide or the polypeptide chain to begin to grow. And the A site is where the charged tRNAs enter and go in. EFG, that's a translation factor. It helps the ribosome move one codon in the 3' direction of the mRNA. And then IF3 is a translation factor that guides the mRNA to the 30S ribosome subunit. And then asks about some codes for initiation and termination. So the start codon is 5' AUG 3'. AUG 3, and then this will always be for initiation. It'll always be this the start codon, and then the stop codon. There's 3 different ones, but the mRNA sequence will always be 5'. Well, it'll always start with a U, and then it'll either be A or G. So it can be an A or a G, and then if it is an A, it'll always be either an A or G with that, or if it's a G, then it'll be an A, and that'll be the for the stop codon. And then a term that indicates that more than one code can specify the same amino acid, that's degenerate. And then the last one is a final amino acid located on the end of a polypeptide, that's the C terminus. So if you have a long chain of amino acids, methionine and lysine and blah, 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 it will always end with that letter.
Okay, so for question number 3, it asks you to use the wobble rules and provide an anticodon sequences. And so for the first one, it gives you UUG, and then there's going to be AAU, AAA, and AAC. For the anticodons, no I's in this one because G doesn't code for the I. For B, we have, we're given AGU, and so the anticodons for that will be UCI, UCU, UCA, UCG, and U codes for all of these ones on the wobble base, which is always the third base pair. And then for C, it gives you UAC, and the anticodons for that are AUI, AUA, and AUG. For part D, the mRNA codon they give you is AUU, and so the tRNA anticodons will be UAI, UAU, UAA, and UAG. And then the mRNA given in part E was GCA, and so you're going to get the tRNA anticodons of CGI and CGU. And if you just look at the wobble base table on PowerPoint, then you'll be able to determine the changes in the third base for all of these.
Sweet. So the next one was all math-based problems. With it gives us the amount of Daltons that the amino acid is, and then asks us to find certain things based off of that. So the first one says that let me read it here. An average amino acid is 125 Daltons, and protein X has 218 kilodaltons in its molecular weight. So 218 kilodaltons is the same thing as 218,000 Daltons. So I just divided that by 125 Daltons to get how long it is, because we know 125 is one amino acid, or sorry, we know that that there are 125 Daltons on here, and 125 Daltons is one amino acid. So that gives us 1,744 amino acids. So the second part of this one asks about, it says, what is the length of the mRNA coding region responsible for producing protein X? So we know that there's this many amino acids, and so if we times that by the number of Daltons, then we will get the number of nucleotides, which is 5,232. Next one asks us about how many GTP molecules are consumed to synthesize each copy of protein X. So it takes 2 GTP in the elongation stage and 1 GTP at termination. And so to create a chain with this many amino acids, we will need to have 2 GTP for each amino acid stuck on there, and then 1 at the very end for termination. So in total, that'll be 3,489. And then asks us how many ATP will be on this chain. And so for each tRNA, for each amino acid, we will have 1 tRNA. And we only need 1,744 ATP, same amount as amino acids, for us to charge all the tRNA. And so that's how we got the answer that we got. 1 ATP to charge 1 amino acid. And then the last one asks about a group of enzymes that consume ATP to assist in the synthesis of protein X. And those are called amino acetyl tRNA synthetase. I hope I pronounced that right.
All right. So for the last question, it gives us a list of proteins and nucleic acid sequences involved, and you're just given 5 questions and asked to pick the list of words that is associated with each question. For part A, it says which of the above is involved in translation initiation, and that should be IF2, tRNA FMET, the start codon, which was the 5' AUG to 3', IF3, the Shine-Dalgarno sequence, and also 16S-RR. Part B asks which of the above is involved in translation elongation, and that's going to be our 23S RNA, EFG, EFTU, and the 16S RNA. And then part C asks about translation termination, and you're going to have the stop codon, which is the 5', 3' UGA, and then the RF1. And then part D asks which of the above is a component of the 70S ribosome, and it's composed of the small subunit and the large subunit, which are the 16S and the 23S rRNA. And then part E is which of the above is found within the mRNA, and that should be the Shine-Dalgarno sequence, the 5' UG A3', and then the 5' AUG A3'. And that's all.
Thanks for watching, guys.